The ocean can be a mirror of calm, yet beneath its surface lies a restless force capable of unimaginable destruction. Imagine standing on a sunlit beach, waves gently lapping at your feet. Suddenly, without warning, the sea retreats, exposing the ocean floor, and then rises again as a towering wall of water, racing toward the shore. In seconds, a quiet morning becomes a scene of chaos. This is the world of tsunamis, sudden, devastating, and often invisible until it is too late. But what triggers such immense power? Beneath the waves, the Earth's crust shifts. Massive underwater earthquakes, landslides, or volcanic eruptions displace vast volumes of water, sending energy rippling across the oceans. Tsunamis are nature's silent messengers, explains Dr. Eleanor Morales, a leading oceanographer. They warn us of the hidden forces moving beneath our planet, forces we cannot see but can never ignore. Coastal cities, home to millions, sit directly in the path of these invisible giants. Low-lying islands, bustling ports, and tropical resorts alike are at risk. Their fates dictated by phenomena occurring hundreds of kilometers away. The stakes are global. Human lives, infrastructure, and fragile ecosystems hang in the balanced dot in this documentary. We embark on a journey from the hidden triggers beneath the ocean floor to the waves that crash on distant shores. We will trace the science behind tsunamis, explore the stories of those who survived, and uncover the innovative technologies that aim to protect humanity. This is a journey into a world where water becomes a force of awe and terror, reminding us of the power of nature and the importance of understanding it before it strikes again. Beneath the surface of the world's oceans, immense geological forces are constantly at work. Tectonic plates, colossal slabs of Earth's crust, drift atop the semi-fluid mantle below, colliding, sliding, and sinking in a slow but relentless dance. At their boundaries, immense energy builds silently over decades or centuries. When it finally releases, the result can be catastrophic. The Earth is alive beneath our feet, says Dr. Rajiv Kumar, a geophysicist. Plate movements are slow, imperceptible, but their consequences can ripple across oceans in minutes. Subduction zones, where one plate dives beneath another, are particularly dangerous. Here, underwater earthquakes can displace vast volumes of seawater almost instantaneously, triggering tsunamis that surge across entire ocean basins. The 2004 Indian Ocean tsunami, which claimed over 130,000 lives, is a haunting reminder of nature's fury. Coastal communities, often unaware of the underlying threat, face devastation in moments. While the origin of the wave lies hundreds of kilometers beneath the waves, history offers echoes of these underwater catastrophes. Ancient chronicles describe cities swallowed by the sea and islands vanishing overnight. These events, often recorded as myths or legends, now gain clarity through modern science, revealing the predictable patterns behind the seemingly random destruction. From Japan's 1707 Hoei tsunami to the Lisbon disaster of 1755, humanity has repeatedly faced the raw power of sudden waves. The mechanics of a tsunami are distinct from ordinary ocean waves. A gentle ripple travels along the surface, but a tsunami is a colossal pulse of energy moving through the entire water column. From the ocean floor to the surface, As it approaces shallow waters near coastlines, the wave slows, grows taller, and funnels through bays and inlets, turning into a devastating wall of water. What makes tsunamis truly terrifying, notes Dr. Morales, is that they carry the momentum of the deep ocean to places we consider safe, transforming miles of calm sea into an unstoppable force. Understanding these forces is crucial. By studying tectonic movements, historical records, and wave mechanics, scientists can predict potential tsunami-prone areas and develop early warning systems. While the ocean's surface may appear tranquil, beneath it lies a hidden world of energy, patiently waiting, reminding us of the thin line between safety and catastrophe beneath the ocean's placid surface. Colossal forces are constantly at work. Earthquakes, sudden shifts of tectonic plates along fault lines, are the primary triggers of tsunamis. In some cases, massive underwater landslides, where mountains of sediment collapse into the depths, displace water with deadly force. And then there are volcanic eruptions beneath the sea, their explosive energy sending shockwaves through the water column. Every tsunami begins with a hidden trigger, explains Dr. Eleanor Morales, oceanographer. A quake or an eruption might happen thousands of meters below the surface, yet its impact is immediate, traveling vast distances at incredible speeds. Once triggered, the tsunami race begins. Unlike normal waves that ripple across the ocean's surface, tsunami waves carry the energy of the entire water column from the seafloor to the surface. In the deep ocean, they travel silently, often less than a meter high, but moving at jetliner speeds, over 500 miles per hour. Ships crossing the open sea may not even notice them, yet the energy contained is enough to wreak havoc thousands of kilometers away. Animation models allow scientists to visualize these pulses as moving walls of energy, stretching across entire oceans. Watching a tsunami propagate is like seeing the heartbeat of the Earth itself, says Dr. Kumar. AGEOPHYSICIST. As the wave approaches land, its nature transforms. Shallow waters force the wave to slow, compress, and grow in height, sometimes reaching tens of meters. Coastal topography funnels the wave into bays and inlets, amplifying its destructive potential. What began as an imperceptible swell can become a towering wall, crashing onto shorelines and inundating communities within minutes. These dynamics make prediction complex, as every coastline reacts differently depending on underwater contours and bay shapes. Monitoring these unseen giants requires advanced technology. Seismographs detect the tremors that may trigger tsunamis, while networks of buoys, called dart systems, measure minute changes in sea level in real time. Satellites provide global coverage, tracking wave speed and energy across entire ocean basins. Together, these tools allow scientists to issue early warnings and map potential inundation zones. Our eyes beneath the waves are improving every year, notes Dr. Morales. With real-time data, we can give communities crucial minutes to evacuate and prepare. Research and modeling continue to unlock the mysteries of tsunami behavior. Supercomputers simulate wave propagation, accounting for factors like ocean depth, coastal shape, and sediment composition. Machine learning and predictive algorithms now help forecast wave height and arrival time with unprecedented accuracy. These advancements are vital for disaster planning, allowing authorities to identify high-risk regions and design evacuation routes. Yet, despite technological progress, nature remains unpredictable. Each tsunami offers new lessons, revealing nuances in how energy moves through water and interacts with land. Understanding tsunamis is not just an academic pursuit. It is a race against time. From the earthquake or eruption beneath the waves to the towering wall striking the shore, every stage is critical. By studying triggers, wave dynamics, and predictive systems, scientists aim to save lives, protect infrastructure, and mitigate the fury of nature. In this chapter of our journey, we see how invisible forces transform oceans into carriers of immense energy, a testament to both the planet's power and humanity's ingenuity in decoding it. When a tsunami strikes, its force is immediate and indiscriminate, sweeping away human lives, homes, and livelihoods in seconds. The human toll can be staggering, leaving communities in shock and grief. Entire villages vanish, schools, hospitals, and markets are reduced to rubble, and the survivors face the challenge of rebuilding amidst loss. Beyond the human tragedy, the environmental impact is equally profound. Mangroves and coral reefs, natural barriers that buffer waves, are destroyed. Wildlife habitats vanish, and ecosystems struggle to recover from sudden saltwater intrusion and debris-laden waters. A tsunami doesn't just hit people, says marine ecologist Dr. Sophia Lin. It disrupts the delicate balance of coastal ecosystems that have taken centuries to develop. Economic devastation compounds the suffering. Ports are destroyed, fisheries collapse, tourism disappears, and infrastructure lies in ruins. Communities face years, sometimes decades, of recovery. Insurance systems are strained, governments scramble to mobilize resources, and families are forced to start over from nothing. The 2011 Tohoku tsunami in Japan left billions of dollars in damages, reminding the world of the massive economic stakes involved in coastal disasters. The cost is not just money, explains urban planner Marco Hernandez. It's the loss of social fabric, the disintegration of everyday life, and the long road to recovery. Early warning systems, however, have begun to shift the balance. Networks of buoys, seismographs, and satellites monitor the oceans constantly, sending alerts to governments and communities within minutes of detecting a triggering event. Drills and evacuation plans, when properly executed, can save thousands of lives. Communities that once had no chance now have the ability to respond, evacuate, and survive. Preparation is literally life-saving, says disaster management expert Naomi Tan. Even a few minutes of warning can change everything. Yet vulnerability remains uneven across the globe. Low-lying islands, densely populated deltas, and nations with limited resources face the highest risks. Asterisk. Maps reveal the most exposed regions, from Southeast Asia to the Pacific Islands, highlighting where human resilience is tested against the fury of nature. Urban expansion, climate change, and rising sea levels exacerbate the danger, increasing both the frequency and intensity of disasters. The lessons are clear. Understanding the science of tsunamis is crucial, but so is translating knowledge into action. Preparing communities, protecting ecosystems, and investing in resilient infrastructure are essential steps toward mitigating the impacts. As our planet's population grows along coasts, the stakes continue to rise. Humanity must coexist with these hidden giants of the ocean, respecting their power while harnessing science to protect lives and livelihoods. The question is no longer if a tsunami will strike, but when and whether we will be ready when it does. The story of tsunamis and mega waves is a tale of hidden power, of energy silently accumulating beneath the ocean's surface, only to erupt with unstoppable force. Through centuries of observation, historical records, and modern science, humanity has begun to understand these phenomena. How tectonic plates shift, how underwater landslides displace water, and how volcanic eruptions can trigger waves that race across entire oceans. Every tsunami teaches us something new, reflects Dr. Eleanor Morales. The more we study, the more we appreciate both the danger and the elegance of these natural forces. Yet knowledge alone is not enough. Staying vigilant requires constant research and continuous monitoring. Seismic networks, buoys, and satellites have transformed our ability to detect potential events, providing early warnings that can save countless lives. Drills, education programs, and evacuation strategies turn data into action, bridging the gap between science and human safety. The challenge lies not in understanding tsunamis, but in ensuring that preparedness reaches every vulnerable community. Looking ahead, innovations in prediction, modeling, and coastal resilience offer hope. Supercomputers can simulate wave behavior with unprecedented precision, while engineering solutions, sea walls, elevated structures, and natural barriers like mangroves reduce the impact when waves arrive. Global collaboration ensures that lessons learned in one part of the world benefit others, creating a network of knowledge and preparedness. As we gaze at the horizon, humanity stands on the edge of both awe and caution. The ocean's hidden giants will never disappear, but with science, vigilance, and foresight, we can coexist with their power. In every coastal city, every island community, and every early warning center, the message is clear: respect the deep, prepare for the unexpected, and never underestimate the quiet force beneath the waves.